All right. Today's new topic, guys. Today's new topic, exponential functions. Look, in the past, in the previous classes, and in the first term, we talk about a different type of function, right? Different types of functions. We know linear functions, quadratic functions, polynomial functions, rational functions, and today we're going to study exponential functions, all right? Yes, ninth grade can be seen as the grade of functions. Yes, that is what you guys study in ninth grade. All right, so let's start with the simplest, with an example. I want you guys to go ahead and read this example, please. Go ahead and read this example. Give it a try. Look at my screen and read it. Tell me if you understand the idea. Got it? Did you get the idea? All right, cool, right? So we're going to try to help John accomplish this, all right? We're going to try to help John. So he wants to get more followers, right? He wants to get more followers in Instagram. And what he's going to do is for each of his followers, he's going to try to get 2 new ones. Hey, Marino, how you doing, brother? You good? Okay, cool. So let's take a look at this table. This will be the table of data, right? So at the beginning, he has just 1 follower. And that guy is going to get John 2 new followers, right? So now he has 2. You get it? Cool. Now, each of these two is going to help John get 2 new followers, right? So the question is, how can we figure out the number of new friends for any step? In other words, what is the number that goes here at step 2? How many followers is John going to get at step 2? Anybody in the chat? Yes, Juli. Thank you, Marino. Alba, thank you, brother. All right. Everybody else, thank you, guys. Thank you for writing in the chat. Thank you. 11 answers. All right, guys. Thank you. Appreciate it. All right. It's a pretty simple answer, right? Thank you, Ali. It's a pretty simple answer, right? So if each of these guys is going to give John 2 new followers, what we do is we multiply 2 by 2, right? So we get 4, right? Beautiful. How about next? Each of these 4 followers is going to get John a new 2 followers. So how many followers is he going to get next? Anybody in the chat, please? Everybody. All right, let's see. All right, we have a lot of answers. Okay, all right. We have a lot of answers here. Okay, all right. Take a look at this again. Each of these 4 followers is going to give John 2 followers, right? So the first of these 4 is going to give John 2. The second of these 4 is going to give John 2. The third is going to give 2, and the last one is going to give another 2. So we get a total of 8 followers, right? Again, 4 times 2. Beautiful, guys. Thank you. Thank you for writing down your answer. All right. Again, if we expand this idea to get the next number, we can see that all we need to do is multiply the previous one times 2. So the next one will be 16, right? 16 followers in step 4. How about step 5? Everybody in the chat, please. All right. Extremely difficult question, right? No. This question is so awful, man. 32 new followers. Correct, guys. Correct. Now, if we continue with this is in only step 5. Guys, do you think this process is a good process, or do you think it's maybe too slow to get followers this way? Like by step 20, look, in step 5, we only get 32. In step 4, we only get 16, right? So by step 20, did you think the guy is going to get not so many followers, or a big amount of followers? Take a look at the increase. What did you guys say in the chat, please? A lot of summoner, a lot of followers, or not so many followers? Look, I'm not asking you for the number, right? So we don't really know about the number. We're not thinking about the number. We're just thinking about if the increase is going to be enough to give John a good amount of followers. All right, a lot of people are saying a lot. Okay, cool. Well, the reality is, man, I have no idea. That's the reality. I have no idea. I will have to continue doing this 32 times 2, and then times 2, and then times 2, and then times 2, and times 2, times 2, times 2. I'll have to do all of that until I get to step 20 to be able to know the amount of followers in step 20, right? But what if there was a way for us to jump this process? Instead of multiplying these, take a look here. Notice that we multiply the same number in each step, right? So we multiply it in the same step, we multiply times 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, right? We jumped to that conclusion a little bit earlier. Now, we can write a function like this. The new friends, that is the name of the function, new friends, is going to be 2 to the x. And if we replace the number x by the step, we are going to get the amount of followers in that step. In your calculator, please, tell me how much is 2 to the 5. 2 to the 5th power. 2 to the 5th power. 2 to the 5. 2 elevated to the 5th power. Thank you, Vale. All right. Thank you, David. Can you see that? So, haha, all right. A lot of people are doing this. Okay. So, good. Look, in step 5, I could have just multiplied the 1 times 2 and the 2 times 2 and the 4 times 2 and the, right? So I could do the chain until step 5 to be able to get the followers. But with the new function, I could just jump all these steps right into the step that I want. For step 5, I get exactly 32 followers. So tell me, guys, please, in the chat, how many followers is John going to get at step 20? Which, okay, all right. I couldn't even finish the question. All right, you guys are on fire today. All right. How much is that? Is that a good amount or is not? Would you like to have that amount of followers on Instagram or not? Huh? I mean, those are a bunch of numbers, but is that number a good number, a big number? Does John's strategy work or not? I think John's strategy works because it looks at the beginning like he's not getting many followers, to be honest. I mean, at 5 days, let's say these are daily, right? Let's say these are daily. So at 5 days, he gets 32. That's not too much. That's not too many. But at 20 days, he gets over 1 million. That's the number you guys have over there. Over 1 million followers. If this was a YouTube account, the guy has one of those, I don't know, YouTube buttons, right? 1 million followers. Wow. In only 20 days. This is called the exponential behavior, guys. So whenever you multiply one step by the same number over and over and over, that is called the exponential behavior. And as you can probably understand by this example, exponential behavior is extremely high. Extremely big, extremely high. All right, let's jump. This was just an example, right? An introduction. Let's jump into the real mathematics here. An exponential function, right? Any exponential function is a function of this form. One value times another elevated to the x. C times a to the x. All right, go ahead and write this down, please. Now, we have some characteristics for these two values, c and a. The first one is that a cannot be 1. Remember, this is the sign for different, right? a is different than 1. The moment one of the functions is 1 to the x, that means that is not an exponential function. All right? Cool. And also, this function over here, c, this value here, c, cannot be 0. C has to be different than 0. Because otherwise, we will have 0 times anything, and that is 0. So that is not an exponential function. These two characteristics are extremely important. All right. From here, let's talk about the domain of this function. Remember about rational functions? Remember rational functions? Where we talk about the domain of functions, right? We had to do some exclusions, right? Well, in this case, we don't have to do any exclusions. Look at this. The domain of the function of any exponential function, it doesn't matter which one, the domain will always be all the real numbers. Go ahead and write it down. It doesn't change. So if I ask you in a quiz, write down the domain of this function, you know I like you because the domain doesn't change. It's always the same. Just write down all real numbers and you are good to go. All right. Couple of other things. Look, the base a, this is called the base, right? The base, the value a is called the base, right? That a is also called the growth factor. So in our previous example, the growth factor was 2 because we took every number and we multiplied by 2. 1 times 2, 2 times 2, 4 times 2, 8 times 2, right? That is the growth factor. And it can be seen here in the value of a. The base a is the growth factor. So if we were to write down a function for this one, this example, the function will have a value a of 2. That is the exponential growth. Get it, guys? The growth factor, sorry. All right, and also the value c has a specific name. The value c is called the initial value. The initial value is the value at the beginning. Well, I'll explain this a little bit further later. All right, just make sure you call c the initial value. So let's make a couple of examples. Tell me, guys, for the first function that we have here, this is an exponential. All of these three are exponential functions, right? All of these three are exponential functions. Tell me, just for the first one, for the function f, what is the exponential growth? The exponent, what? The growth factor. Sorry, that's the name. The growth factor. What is the growth factor? All right. Thank you, guys. You're correct. Thank you, guys. The growth factor is 2. How do we know? Simple, because 2 is the value that is being elevated to the x. 2 is the value that is being elevated to the x. So 2 is the growth factor, the base of the exponential function. Beautiful. But what about the initial value? Yes. Yes.
¿Puede volver hacia atrás en la anterior diapositiva, por favor?
Here?
Sí.
Absolutely. Take a picture, brother. Take a picture so that we can move on.
Gracias.
Sure. Cool. All right. So we know now that the growth factor is 2. But what about the initial value? Again, write it down in the chat, please. What is the initial value? All right. Man, look, I don't know if you're copying from your partner or you really understand this topic, but you guys are correct. You are correct. The initial value is 1. Why? Because there's nothing there. There is nothing there, right? And in math, when we have nothing, there's a 1. This is 1 times 2 to the x. Just 2 to the x, right? Beautiful, guys. All right, let's take a look at this. The base is 2, that is the growth factor. The base is 10, that is the growth factor. And in the last one, even though the exponent is x plus 1, so the exponent is just not an x alone, this is still a good exponential function. Why? Well, because the exponent includes the variable x. It doesn't just have to be x alone. It can be x to the 2, for example. That is a good exponent. 3 to the x squared. That's awful, but it works. It works, right? So the base here is 3, right? Those are the growth factors. Guys, quick question. Let's see if you get this one. Which one of these 3 functions is going to increase faster? So by step 20, which of these functions is bigger? That's the question. Increasing faster means in a high step, which one has a bigger number? Okay, thank you. Some of you are answering. Check. Look, let me show you this. Let me show you this. Let's take a look at this table here. Do you guys remember when I said the growth factor was 2? Okay, the growth factor is 2 because I am multiplying every step by 2. So 1 times 2, and 2 times 2, and 4 times 2, right? What if I said the growth factor was 3? Okay, then in that case, I would have 1 times 3, so 3, right? And then 3 times 3, which is 9. And then 9 times 3, which is 27. And 27 times 3, right? Did you get it? So a bigger growth factor means the function is going to increase at a faster rate. Let's take a look at our functions again. Anybody wants to change their answer? What is the function that increases the fastest? All right. Beautiful, guys. Thank you. Thank you for answering. Thank you. So you guys are correct. The function that increases the fastest is g. Of course, you might be thought, you may thought at the beginning, well, this exponent has a +1. That means this is bigger than everyone else. Sure, but in this case, the main reason why a function increases faster or not is the growth factor. So the base, this one is base 10. This thing is going to increase incredibly faster. Incredibly fast. All right. Beautiful. So now we had some examples, right? Let's study what is called evaluating a function. Evaluate. Let me open block de notas. Block de notas. This is what this is called. Evaluating a function. Evaluar la función. That is the name. Evaluar la función. En un examen, en un quiz, si les pregunto, evalúe la función f cuando x vale 2, estamos haciendo esto de acá, mira, el valor de f, la función, cuando x vale 2. Evaluate the function, the value of the function f when x equals 2. This is what we're going to do, right? And what is that? What is to evaluate? All right, to evaluate a function, all we have to do is change the value of x by the value that we are given, So if I change x, I'm going to change it here, and I'm going to change it here. Take a look. F of 2 equals 3 to the 2. That is 9 in this case, right? 3 to the 2 is 9. So evaluated a function at the end gives me just one answer. We just evaluated the function. This is called evaluating a function. All right? Beautiful. But what is the evaluation of the function if x equals -2? How much is that? Again, to evaluate the function, all we have to do is change x by the value that we are given. So f of -2 equals 3 to the -2. That is 1 over 9. Of course, you can put this in a calculator, and your calculator will give you a different answer. It will give you some decimals, right? Well, guess what? Those decimals are being round. Those decimals are being round. So this that I have here, this is the precise answer, the exact. Let me write it here. Exact answer. Sorry about the handwriting. I'm writing with my mouse, so looks awful. Sorry, guys. And the reason why this is an exact answer is because we are using this sign. This is the equal sign, right? So we are being specific about the answer. We're being really, really specific. If we want to write down the decimal, right, the round, it could be, I don't know, 0.0 1, 1, 1, for example, right? That could be an approximation. Then if we approximate, we have to use the symbol for approximations. And this is no longer an exact answer. This is now an approximation. Let me write it here. Whatever, approximation. You guys got the idea, all right? An approximation. So guys, knowing what to write gives you full marks during a question. If I'm asking you to write down the exact answer, do not use the calculator, because the calculator will not give you an exact answer. You have to write it down like this, using the properties of math, right? I don't know if you remember this. Hopefully you do. But 3 to the negative 2 is the same as 1 over 3 to the 2. I don't know if you remember this. Look, the sign here was negative, and now the sign here is positive. You can change the sign of an exponent if you move it as a denominator. Right? Did you guys remember about this or not? Okay, one of you did. Two of you, three of you did. Okay, cool. Thank you, guys. All right. This is a property of the exponents, right? If you don't know properties of the exponents, then you're going to have to study. You're going to have to go on Google and write down properties of exponents. And that's it. All right. Exact answer and approximation. Beautiful. Let's jump into this. Guys, go ahead and tell me, what is the answer here? How much is g of x when x equals 4? Using the calculator, your calculator, please tell me, how much is that? Juan Camilo is not multiplying. It's being elevated, right, as an exponent. All right, thank you, brother. Lauanzola, Samuel, Juliana. All right, anybody else? Let's evaluate the function g when x equals 4. All right, man, I have some answers. All right, beautiful. Cool. So how do you do that? Simple. Instead of x, write the value of x. Write the value 4 in here. Every single question is giving you a different value, so you just replace. Here we have g of 4 equals 0.5 to the 4. Put this in a calculator and we have 0.0625 and we are good to go. That's it. That is it. Now, we can also do this without a calculator. I'm not going to lie to you guys. If this was a quiz in the school, I will not do this with the calculator. You have to do this without the calculator. But how, teacher? No, I don't know how to do that without the calculator. Yes, you do. Because 0.5 is 1/2. And now we have 1/2 elevated to the x. If we do g of 4, we are doing then 1/2 elevated to the 4. And this means we're going to do 1 to the 4 and 2 to the 4. So this is 1 to the 4 is 1 and 2 to the 4 is 16. So you can do this without the calculator. Magic. All right, guys. Okay, cool. Listen, we are doing this online, right? So you can use your calculator as much as you want. But I just wanted to show you that this is possible without the use of calculator. All right, let's continue. Let's talk about the graph of an exponential functions. Let's talk about the graph. All right, guys. Let's talk about what is exponential growth and how to detect exponential growth, and what is exponential decay and how to detect exponential decay. Look, in some questions, I am going to ask you, according to this function, tell me if that is exponential growth or is that exponential decay. Right? So you're going to need to know what it is and how to know. All right. We have 3 ways of knowing how. We have 3 ways of knowing if it is exponential growth or decay. Number 1, by taking a look at the data. Here I have 2 tables with data. These are the values of the functions. I have not shown the functions, but I am showing the data, right? When x equals 0, the value is 3, right? The function is 3. When x equals 1, the function is 15. And as you can see, the function just increased in value, right? From 3, it went up to 15. When x equals 2, the function equals 75. And again, we are increasing in value. From 15, we went up a lot to 75. Last but not least, when x equals 3, the function equals 375. Again, we are increasing in value. So that is the first characteristic. Exponential growth means, just like the name implies, a growth in values. So every single one of these values of f, the function, are going to increase in every step. This is called exponential growth. For our example with John and Instagram and the followers and all of that, that was an exponential growth. Because in every step, John was getting more and more followers. The values of the function were increasing. That is exponential growth. You can see that from the table. Right, guys? Did you get that or not? Cool. Thank you. All right. Thank you, Samuel. Thank you, Marino. All right. Thank you, Lau. Beautiful. How about exponential decay? Decay. I don't know. I think it's decay. Is it decay? Decay. I think it's decay, right? Whatever. Exponential decay. How do you recognize it? Again, take a look at the values of the function. When x equals 0, the function equals 32. But when x equals 1, the function equals 16. That means the value went down a little bit. We don't have an exponential growth. And remember, growth means the values are going to go up. In this case, the values are going down. Look, when x equals 2, the value went down to 8. When x equals 3, the value went down to 4. This is called exponential decay. We have the values decreasing, right? The values are decreasing. That is the idea behind exponential decay. All right, go ahead and write this down, guys, please. And that is the main way, or one of the first ways of recognizing how to know if the exponential function has a growth or has a decay. Decay. Let me write it. Let me find it in the translator. Translate. Decay. All right. Decay. It's not decay, it's decay. All right. Decay. Beautiful. But there are two more ways in which we can know for sure if the function has a growth or a decay. Decay? Decay. Sorry. Decay. All right, this is how. You guys, instead of looking at the data, you can take a look at the functions. Look, here I'm giving you the functions that I had at the beginning. The first one was 3 times 5 to the x. And the second one was 32 times 1/2 to the x, right? These are the two functions. If we change the values of x by 0, we're going to have 3. If we change the values of x by 1, we're going to have 15. X by 2, we're going to have 75, right? This is the function of the first data. And this is the function of the second data. Again, if we change the value of x by 0, we'll have 32. By 1, we have 16. By 2, we have 8. By 3, we have 4, right? These are the two functions. And if we look at the functions, we can see a key characteristic. Look, tell me, guys, in the first function, the function f, both are functions f, sorry. The first function, the one to the left, what is the value of a? The growth factor. What is the value of a? The base, the growth factor. All right, thank you, guys. The value of a is 5. Remember, here we have the form of any function, right? This is the form of any function. We have c times a to the x. So the number being elevated to the x is the a, the base, the growth factor. So that is 5 in here. That means in every step we are multiplying by 5. Look, 3 times 5, 15. 15 times 5, 75, right? Growth factor, 75 times 5, 375, right? So the growth factor show us if this is a growth or a decay. If the growth factor is bigger than 1, just like I have here, if the growth factor is bigger than 1, it doesn't matter what value though. It just has to be bigger than 1. It could be 2. It could be 100. It could be 1.1. It doesn't matter, right? It has to be just bigger than 1. If the value is bigger than 1, then the growth factor is going to make it so that the function has an exponential growth. It's going to increase in value, right? Again, if a is bigger than 1, we have exponential growth. The values will be increasing. All right. But what happens when the value of a is lower than 1? Here, 1/2. 1/2, that is 0.5. That is lower than 1, right? Any value lower than 1 is going to give us an exponential decay. 0.9, for example, 0.9999999. 1 doesn't work. Remember, a cannot be equal to 1. It has to be lower than 1, right? 0 doesn't work. Otherwise, we have 0 to the x. That doesn't work as well. But we can have negative values. Those are as well exponential decay. All right. By the way, guys, tell me, in the first function, in the first one, to the left, what is the value of the initial? What is the value of c? The initial value. 3. All right. Thank you, guys. You're correct. The initial value is 3. And take a look at this. What is the initial value that you have in the table? 3, right? That happens because the initial value of the function will always be achieved when x equals 0. Please write this down, please. To find the initial value, all you have to do is take a look at the function c. Sure, but you can just see the initial value from the data without using the function, from the data. When x equals 0, that is the initial value. When x equals 0, that right there is the initial value. Write this down somewhere, please. When x equals 0, that is the initial value. And you can have it here. Look, when x equals 0, the value of the function is 32, which happens to be our initial value. Did you see? Again, when x equals 0, that whatever the function is, it will give us the initial value. So let's come back to our data here in the first example. Here, in the first example. Take a look at this. We are multiplying every number by 2, right? So that is the growth factor. Let me write this down here. Just this. All right. So the function, if I were to write down the function, because guys, I am going to ask you to do this. I am going to ask you to do this without calculator as well. So if I have to find the function here, I notice that in every step, I am multiplying times 2. Right? Look at that. 8 times 2, 16. Right? So that means the function, the value of a equals 2. So we have 2 to the x. A equals 2, the growth factor. And what is the initial value? The value c, what is the initial value? To do that, we take a look at the value at the step 0, the value when x equals 0. And that gives us 1. So c equals 1. The initial value is 1. In other words, our function is 1 times 2x, 2 to the x. Huh? Of course, we can delete this to just leave it as this, because we have 1 times anything that is That is the ending, right? It doesn't matter. So this is the function here. All right. Again, guys, I'm going to ask you to do this with and without calculator. So this is how you find it. Yes, find the value of the growth factor and then the initial value. All right. Beautiful. Again, so we have two ways of recognizing if the function has a growth or a decay, right? The first one, by looking at the data. The second one, by looking at the value a in the function. And the third one, by looking at the graph. Take a look at the first one. If we look at the first function, the one on the left, the line, the red line, that is the function, right? If we look it from left to right, always look it from left to right. If we look at it from left to right, we can see that the line is going to increase at some point. Sure, at this first part, the line is not really increasing, right? It's really close to 0. But then it's going to go up. And then it goes up by a lot. The function is increasing, right? Every little step in this line is going up. Va para arribita. So in this case, we know just by the looking, just by the behavior, just by looking at the function, we know that this has an exponential growth. This is the third way we have to recognize exponential growth or decay. By looking at the graph. In this case, look, if we look at the function, again, from left to right, the function from left to right is going down. This is called a decrease. The function is not increasing, the function is decreasing. This is exponential decay. All right, guys, did you get the 3 ways or not? Cool, thank you, Marino. Thank you, Lau. All right, thank you, Alejita. All right, some of you are saying that you get it. Cool, beautiful.
Profe, ¿puedes explicarlo otra vez, por favor?
Sure, Brian, absolutely. Again, look at the lines. The lines are the red ones, all right? These are the functions, all right, Brian? Now, in this case, this line is going up, and this one, the second one, is going down. How do you know? Because you need to look at it from left to right. So if you look at this function from left to right, the line goes up, right? If you look at this one from left to right, the line goes down. So if it goes up, that is a growth. If it goes down, that is decay.
Okay, thank you, mister.
Absolutely, Brian. Absolutely. All right, let's continue. Cool. All right, these are the main 3 ways to find exponential growth or decay when we talk about functions, right? How did you graph functions? As usual, you just put it in a calculator and you know the graph of the function. That is one way. Or another one is you do the table, right? You give values of x, whatever values you want, 0, 1, 2, 3, 0, 1, 2, 3. You can even give negatives if you want. I don't know. -4, -3, -1, -2, 0, 1, 2, 3, 4. Whatever values that you want in x. And then you replace and write down the values for y. Right? That is how you do it. Then you plot those points and you are good to go. Now, this is the moment that I have been waiting for. This is modeling a function. This is the important part of today. How do you model a function? Let's begin by analyzing or just learning what is that? What is to model a function? I want to be a model teacher. No, sure. If you want to model clothes, but this is not the same, right? Modeling a function has a lot more different to do. Modeling a function means to find the function that best fits the data, right? What is this? What is to fit the data? Bueno, aquí paso un momentico al español. En algunos momentos de la clase tendré que pasar al español porque en otros cursos, bueno, me he dado cuenta que aquí se me pierden los muchachos. Entonces, les paso el español para que no se me pierdan. ¿Listo? ¿Qué es modelar una función? Así se llama. Modeling a function. Modelar una función. ¿Qué es eso? Ok, modelar una función es Tratar de encontrar la función, o sea, la ecuacioncita, esta de acá, mira, esta de acá, esta f o esta de acá. Tratar de encontrar la ecuación a partir de un poco de datos. ¿Ok? Tratar de encontrar la ecuación a partir de un poco de datos. Esa es la idea. Ahora, a veces esos datos no son perfectos. A veces uno busca el growth y a veces el growth no es el mismo. O el decay. Perdón, decay. No es el mismo. Entonces la función no nos va a dar perfecta. En este caso de acá, la función es perfecta. Mira, cumple para cada uno de estos puntos. La función de acá también cumple para cada uno de estos puntos. La mayoría de veces la función es perfecta. Pero hay veces que no. En este ejemplo, pues bueno, también es perfecta, pero hay veces que no es perfecta. Por eso pongo aquí que modelar una función significa encontrar la función que mejor se acomoda. Hay veces que no cogemos todos los puntos, pero sí cogemos la mayoría. Eso significa que mejor se acomode. Modelar es un tema que vamos a ver en 10º y 11 también, sin importar la materia que elijan. ¿Listo? All right, to model a function, the first thing you need is a bunch of data. In here to the left, I have a table. I have 1, 2, 3, 4, 5, 6, 7 points. 7 data, right? Each value for x gives a value for y, the function, right? Now, how do we model the function using the calculator? Of course, without using the calculator, I just showed you, right? You need to find the value a and then look for the value 0, right? That is the initial value. So without using the calculator, this is pretty simple because the function is perfect. But if the function wasn't, we can't. We just can't do it by hand. We have to do it with the calculator. This is how. Take a look at your calculator. I'm going to have to use mine as well, right? This is the part where you use your calculators, guys. Step 1. We're going to plot the points. If you know how to plot points using your calculator, then you're good to go. You know, and you can just write this in your calculator and do it. If you don't know, you're going to have to use your calculator and follow my instructions. All right, so let's get out of here, right? Maybe you are something like this, or maybe you have nothing like that, right? The first thing you want to do is go to statistics, right? Once you are in statistics, a bunch of options are going to appear. Now, we don't want to calculate, so the second option, we don't want to calculate any data. We don't want to run any tests. No, we want to edit the information. So we press enter for edit. Now, if you have used this in the past, you already have a bunch of data. What you can do is just delete it. You can press clear and clear the data, right? I am not going to do that because guess what? This data that I have in the calculator is the one that I have here. I already did this step because I don't want to waste my time, right? So in here you write down in the list 1, you write down the values for the x. -3, -1, -2. Momentico, aquí importante. Momentico. Aquí no es -3, -2, -1. Aquí es -3, -2, -1. ¿Por qué les digo esto? Porque muchas personas usarán este botón de acá, el del menos. Y ese no es el botón que queremos. No queremos poner -3. Queremos poner -3, que está aquí abajito. Si lo pones con el menos, te va a aparecer syntax error. Quieres poner es -3, -2, -1. All right? Cool, guys. Once you have finished with this, once you have finished your, putting your data in the table, tell me if you're done so that I can continue. Tell me if you're done, please. All right, Lau is done. Both Laos. Brian is done. Anyone else? Samuel, Juli, Marino. Anyone else? David, Aleja. All right, a lot of people are done. Anyone else? Can I continue? Do I have to wait for you? Thank you, Vale. Do I have to wait for you? No? Anybody needs more time? No? Beautiful. Let's continue then. All right, so now we just have the data in the calculator. So now let's tell the calculator to plot this data, right? Remember, The first step is to plot it, right? So far, we haven't done anything. We need to tell the calculator to plot it. How? If you press graph, you're not going to get anything because you're most likely going to have your statistics plots off. This is the first step. You go to second, and here, on top of y equal, you're going to find the word stat plot, right? That is the blue one. That is why we press second. Second, y equal. And we get this menu. This is the statistics plot. Since we are going to plot the points, we want statistics plots, right? Press on the first one. You can change, of course. You can change to second, one, third. Just press on the first one. And you are most likely going to have yours as off, right? So what you do is you do on. You press on. You make sure that your plots are on. Now, after you're done with that, make sure that you have the correct type of function. The correct type of function. Look, we can have a scatter plot. That's the first one. That is the first type of function, scatter plot. Or we can have the second one, which is a line graph, right? Or the third one. This is called a histogram, right? A histogram, or a bar graph. We can have a box and whiskers, or maybe another box and whiskers. And I have no idea what is this, right? Now, if I ask you to plot the points, what type of function do you think, or what type of graph do you think you need? A line graph, a bar graph, scatter plot? Which one?
The first one.
The first one. Thank you, Alba. The first one is the one we need. So we go to the first one and we press enter. Now, like that, we are sure that the graph that we are gonna get is a scatter plot. All right. For X list, make sure it's on list 1. And for Y list, make sure it is on list 2. Because those are the positions on the table that we put our data. If you change list 1 by any other list, then the function is not going to work, right? The graph is not going to work. A propósito, puedes cambiar esos valores si quieres. No sé por qué quisieras, pero si quieres los puedes cambiar acá. Mira, mira las teclitas, ¿listo? En la parte de arriba de las teclitas puedes encontrar las listas, ¿no? Mira, aquí se ven azulito. Listas 1, lista 2, lista 3, lista 4, lista 6. Si digamos que yo quiero cambiar esto por la lista 6, no me sirve de nada, pero si quisiera cambiarlo, presiono segundo 6. Mira, ahora tengo en la lista 6. Eso me sirve de nada, entonces lo voy a regresar. Second 1. Ya tengo la lista 1. ¿Ok? Ah, a propósito, no les dije lo del emulador. Mira. Se llama el emulador. Ese emulador funciona para iOS. Perdón, para Android. Esto es con W. Wabitemo. Esto es con W. ¿Listo? Ahí descargan el emulador, seleccionan el tipo de calculadora. En este caso estamos utilizando la TI-84 Plus. Si no tienen el Plus, también pueden poner la TI-84. Cuando descarguen el emulador, si quieren descargar el emulador, les va a preguntar ¿qué calculadora quieres? Ese emulador es tan bueno que tiene todas las calculadoras de Texas. Son muchas. Entonces uno descarga la que quiere uno trabajar. En este caso estamos trabajando, mira, con este TI-84 Plus. TI-84 Plus. Esa es la que queremos. Bueno, ojalá eso le haya servido a alguien. Creo que también hay una para iOS, pero creo que es pagando, entonces no sé. ¿Ok? No se preocupen por esto. Esto no es un virus, esto no sé, no les voy a robar sus datos, esto no es TikTok, ¿listo? No se angustien por esto, mis niños. Esto es una vaina segura, ¿listo? All right, let's continue. So now that we have our list 1 as L1 and our Y list as list 2, we are good to go. We can skip here. All we have to do is press the graph button. Here, graph. And this is going to appear. The graph of the dots. Okay, we did it, guys. All right. Now, this is the part where you tell me your mistakes or your errors, right? But teacher, I don't know. It says syntax error. whatever. Tell me, and we'll see how we can fix it. Ah, teacher, my graph, my points don't look like yours, huh? Look, if that is the case, we can change it here in the window. Press the window key, and we can change the values. We need to make sure what values did you choose. You can choose the ones that I have, or you can choose your own. All you need to realize is that look, if you go to statistics and again edit, these are the values, right? So we can analyze what are the perfect values for our table. In the first one, the X list, right? This is the values for X. My values for X go from -3 to +3. So I have to select values according to that. That is why I choose to select -5 as a minimum and +5 as a maximum. Look, window, -5 as a minimum and +5 as a maximum. Okay. But again, the values in the second list go from 8, that is the maximum, and then they decrease to 0.125. So I selected 10 as a maximum and -1. I could even say 0 as a minimum. Look, no. Window here. For Y, a minimum of -1 and a maximum of 10. Of course, the scale, look, X scale and Y scale. These are the scales. Las muesquitas, las lineecitas estas son las escalas. I set 1 because I want every line to show a value of 1. And then I press graph. That is my table. Is anybody of you getting a different table or having a difficulty with this or not? You okay, guys? All right, that's beautiful. Thank you, guys. Let's just wait a couple of, just maybe 1 minute, 2 minutes to wait for everybody else to finish, all right? Let's just wait a little bit. Let's just wait a little bit. Let's just wait a little bit. Okay, I think that's enough. I think that's enough. All right, let's continue with this. So congratulations. Look, first, plot the points. Now here. Now we have the points plotted. Of course, look, let's come back. Let's say we are in this screen. Here. We're in blank, right? And I give you a bunch of data to plot. So you go to statistics, right? Edit. You introduce the data, right? Blah, 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 bunch of numbers, enter, la, 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 la. You introduce the data, right? Cool. Do you still have to go to do second Y? Do you still have to do this step? No, you don't, because you already activated this. You don't have to do this step. So right from here, right from the data, all you have to do is graph, right? Because we already activated the statistic plot. Great. Now, to some of you, you may have these points and also a line, right? Maybe a line, I don't know, any other type of line. That is because in your Y equal, here, in your list of functions here, Y equal, I just press this button. This should be clear. This should be clean. Nothing should be here. If you have something here, then that is the reason why you have a line instead of a bunch of dots. All right, erase it, please. Just like I do. I don't have nothing there. All right. Cool. Beautiful. Let's jump into the second step. Second step. First, plot the point. Second, analyze the behavior. What? What is this? Okay. Analyzing the behavior is probably the most important step when we model a function. Analyzing the behavior is taking a look at the data, taking a look at the graph, and analyzing what type of function this data could make. Pasar un momentico al español. Aquí la gente también se me pierde un poquitín facilito, ¿listo? Recuerden que, mira, los voy a anotar acá. Ojalá les haya servido esto del emulador. Ojalá lo hayan tenido. Yo tengo mi emulador en mi celular. Ok. Hasta el momento tenemos este tipo de funciones. Tenemos lineales. Linear functions, right? Tenemos cuadráticas. Quadratic functions. Tenemos también cúbicas, vimos un poquitín de cúbicas, ¿no? En las polinómicas vimos cúbicas, cubic functions. Tenemos cuartas, quartic functions, ¿verdad? Luego pasamos a las racionales, rational functions. Y la última que aprendimos hoy, exponencial, las funciones exponenciales. Analizar el comportamiento significa ver los punticos que ploteamos y determinar qué tipo de función es la que mejor se acomoda. Por ejemplo, ¿será que los punticos se acomodan a una línea? Pues yo creo que no, ¿no? Mira, de hecho parece que aquí hay como una curvita, ¿cierto? Pareciese que hay como una curvita. Pues entonces no parece que el comportamiento sea lineal. Entonces podemos borrar esta. ¿Me hago entender lo que voy haciendo, mis niños? Entender, analizar el comportamiento, ese es el paso 2. Analizar el comportamiento significa mirar los puntos, por eso los bloqueamos al inicio. Diferentes tablas de datos nos van a dar diferentes puntos. Y ahí es donde analizamos. De esta de acá, yo creo que esta parece una exponencial. Así que decido que es una función exponencial. Digamos que nos den otra. A ver, déjeme hago aquí un ejemplo desde ceros. Listo, a ver. A ver, digamos que este es mi plano. Uy, mi plano me quedó horrible. A ver, trato de hacerlo rectico. Uy, no, peor, pero bueno, voy a tratar de que sea rectico. Y digamos que los puntos que me dan así. Aquí es un punto, otro, así. Aquí viene y gira, y aquí otro, así. Y aquí viene y gira otra vez. Uy, me quedó, esto parece una línea. Aquí un punto, y aquí viene y gira otra vez, y aquí otro punto, y así, y aquí vuelve y va para adelante. Digamos que esos son los datos y los ploteamos en nuestro plano. Los acabamos de plotear. El plano es este plano largote. Ok, pues ¿qué tipo de función mejor se acomoda? ¿Será que es una función lineal? Pues no, esto no es una línea, esto tiene curvitas. ¿Será que es una función cuadrática? Acuerden que la cuadrática son como unas n's y una u, entonces la cuadrática podría ser al menos esta parte. Pero ¿y qué pasa con el resto de puntos? Parece que no se acomoda mucho, ¿no? De nuevo, la cuadrática podría ser esta de acá. Pero ¿qué pasó con el resto de puntos? Hay que buscar la que mejor se acomode. ¿Podría ser una cúbica? Una cúbica sí podría ser. La cúbica, si se acuerdan, la cúbica viene siendo es más o menos como así. Ustedes vieron esto cuando trabajaron en Alex, ¿no? Ok, entonces estos datos podrían estar modelados por una cúbica. Esa es la idea detrás de mirar el comportamiento. Imaginarse qué tipo de función es la que mejor se acomoda. Ok, mis niños, ¿me van siguiendo hasta ahí o no? ¿Sí? Perfecto, mis niños. Entonces aquí ya decidimos que esta es un comportamiento exponencial. Analyze the behavior. This function has an exponential behavior. All right, cool. Now that we had just analyzed it, we can jump into the third one. Look, I said at the beginning, the second step is probably the most important. I didn't say it was the most difficult. The most difficult is the first one, to be honest. Plotting the point takes time. Second one is the easiest. I'm sorry, is the difficultest, but is the fastest. You have to analyze it really clearly, right? For step 3, final step, calculate the appropriate regression. What do I mean by that? All right, take a look at this. We're going to go to do the third step. To do the third step, we're going to press the statistics button again, right? And since I said here that we want to calculate the regression, that means we're going to have to go to the calculate option. We don't want to run tests, so we don't want this option. We don't want to calculate, right? And look, if you go to the fourth option, we have lin reg. What is this, guys? What is this? This is linear regression. This works when we want to find a linear regression, right? If the bunch of data were to give us a line, this is the good regression that we want. But we said we want an exponential function. So we're not going to do linear. Look, if we have said quadratic, this is the quadratic regression. If we said the points show a cubic behavior, then this is the cubic regression. Quartic, then quartic regression. Another linear regression. This is the logarithm regression. We're not doing logarithms here. Look at the data. This looks like an exponential. So we go down even further to exponential regression. If we wanted to, we can have power regressions or logistic regressions. We can have a lot of regressions here. A lot. Which is one, the exponential regression. This is why I call this step calculating the appropriate regression. Because depending on your data, you have to select the appropriate regression. We just said this data was an exponential, so we select exponential regression and we press enter. Are you guys following me here or not? Beautiful. And look at this. The calculator is just going to ask us a couple of things. Number one, X list, list one. Make sure here you have list one. For the second one, Y list, make sure you have the list two. For frequency list, make sure you have nothing. Make sure you have nothing at all there. For store equation, you are not going to use this because I don't know how to use it. This is good for something. This is useful, but I have no idea how to use it. If any of you find how, you can tell me, please. But I don't know how, right? So after we are done with this, we go to calculate and we press enter. The calculator is going to take a couple of seconds and then it's going to show us this. Now, some of you may not have this last part, the R squared and R. These two R's. That is okay. If you don't have this, that is okay. You only care about the Y, the A, and the B. Okay, guys? How do you read the information here? Simple. Take a look at this. Let me just show it like this. All right. These are the information that you want. Remember. ¿Qué es lo que estamos haciendo? Paso al español. ¿Qué es lo que estamos haciendo? Estamos modelando, ¿cierto? Y modelar significa encontrar la función, o sea, encontrar la ecuación. Esta de acá, esta, f de x igual a cositas, f de x igual a cositas. Eso significa encontrar la función. A partir de los datos, encontrar la función. Pues, al final de todo este poco ejercicio, lo que tenemos que hacer es dar una función. Vamos a encontrarla aquí. La calculadora ya nos dio la respuesta, solo hay que saber escribirla. Mira, de la primera línea yo sé que la función toma la forma y igual a por b a la x. Eso es lo que dice ahí. Mira que este cosito aquí, este cosito es el cosito de elevar, ¿no? Por eso es a por b a la x. Voy a poner aquí un paréntesis. A por b a la x. ¿Cierto? Y la pregunta es, ¿pero cuánto vale a y cuánto vale b? Porque si no, entonces no tenemos función. Muy bien, aquí nos dicen el valor de a y aquí nos dicen el valor de b. O sea que la función es y igual a 1 por 0.5 elevado a la x. Ahí está nuestra función. Esta de acá es nuestra función, mis niños. ¿Ya la encontramos? En este punto modelamos, acabamos de modelar esos datos. Ya encontramos la función. ¿Para qué nos sirve esto? Ahora podemos predecir datos. Por ejemplo, en nuestra lista de acá, la lista va de negativo 3 a 3, pero yo les puedo preguntar, ¿cuánto vale la función cuando x vale negativo 200? O positivo 200. Pues eso es muy largo, ¿no? Pues ahora si tenemos la función, no es más sino reemplazar x por lo que yo les pregunté, negativo 200. Se introduce aquí en la calculadora y ya estuvo. Predecimos valores. Para eso sirve modelar, para predecir valores. Encontrar valores que no tenemos en la lista de datos. Encontrar valores que no tenemos en la lista de datos. Para eso es modelar. ¿Ok? Bueno. How do we write this in the calculator? Let's say we want to see this in the calculator, guys. Let's say we want to see that function in the calculator. So all we need to do is go to y equal, not stat plot, no, y equal, here. You should have it clear, right? So what we can do is write down the function that we have. This is 1 times 0.x to the x. So let's write it here. 0.5 elevated to the x. There. Why did I skip the 1? Why did I not put the 1? Well, because it's 1 times 0.5, right? 1 times anything is the same, right? So from here, all I have to do is press graph, and look at that. After a while, the function is going to give us the line. The calculator is going to give us the line. There we go. This is a case where the function is perfect because the function is passing through every single one of our points. Remember, that doesn't happen most of the times. Most of the times you get really close to most of the points, but not all of them. Not all of them. It is okay. It is okay. All right, guys. Thank you for coming. Make sure you do these exercises. Now, we only have a couple of minutes, so we're not going to be able to finish all of these points today, right? We're not going to be able to finish all of these today. Just do as many as you can, and we come back. When we come back to the next class, we're going to continue with this, all right? I'm going to stop the recording here. But remember, if you have any doubts, you can always ask me.